Welcome to the Boolean Algebra rules, and what we're trying to do in this presentation are, we assume you already know about the basic operations such as ands, ors and nots, etc. So why do we need to have rules? We'll go into that in some more detail as the slides go on. We'll also try to explain the rules as well, and in this context it's important to remember that the term rules and the term laws are interchangeable. It's important to understand how the operations behave and interact. Several of the rules are similar to the normal mathematical laws, but they're slightly different. The following sections look at how these rules are applied to expressions to modify and to simplify them. Some of the rules may appear to be a little confusing at first, and the best way to make things clearer are by using a few examples. Don't be put off by the number of rules. It's just like anything really, practice, practice, practice. And it's a lot like riding a bike. Very soon they will become second nature. So now we have the rule of commutativity. This law states that the order of the terms of an expression or a part of an expression within brackets may be reordered and the end result will not be affected. You can see in the slide below there's a couple of examples. This slide just gives some more examples of how you can apply the rule. Take a moment to have a look at them and try to see if you can understand how they work. This is all to do with identity. The identity law observes how certain expressions will behave when one of the terms is fixed. A term in an OR operation with a fixed value of false will return in the term G or false equals G. And similarly, a term in an AND operation with a fixed value of true will result in the term of H and true equals H. Now we look at the complement one. The complement law has to do with a relationship between a variable and the negation of a variable. For example, not C. Consider the following expression. C or not C equals true. If C is false and then not C, it must be true, and vice versa. Either way, one of them is always going to be true and the result will be true. And there's another example just below. The indefinite law. This law applies if a variable is repeated within an expression. Effectively, it may be simplified to itself. So for instance, R or R and R equals R. If you think about this, it makes sense. Both sides of the expression are always going to be the same value as if they are the same variable. Slide 9. The double negation rule. The law states if you negate a negation, if you have a not within a not, they effectively cancel each other out, which makes sense if you think about it. And there's some examples down there. Go through them. They should be fairly obvious by now. Associativity. This law looks at brackets or groupings within an expression and how they may be reorganized or even removed. If all the operations within an expression or part of an expression are the same, then this may be done. And you can read the text below. And again, hopefully that makes sense. If the operators are mixed, then this may not happen. Read the expression below. If it doesn't quite make sense, then try assigning some of the variables to A, B and C and create a good old truth table, which we learnt in the previous presentation, to observe the outcome for both expressions. Truth tables will help to make it clearer in this case. distributivity. This law is similar to what it is in normal mathematics and has to do with expanding or simplifying brackets. This may be done when one of an and or an or is inside brackets and the other is outside, and you can see the example below. Now if you notice, the two variations are the inverse of each other, and that in both situations the operation which is made inside the bracket on one side of the expression is outside the brackets on the other side, and vice versa. This can get a little confusing, but take a little time just to think about it and soon it'll make sense. De Morgan's law. Now this may seem a little odd at first, but in later sections you'll see that they actually become very useful when attempting certain types of manipulation. As stated in a few of the laws before, trying to put variables into a truth table for both sides of an expression will help gain a better feel for how they operate. If you look at the example below and try to put that into a truth table. The absorptive law. This is another one which is useful in simplification, normally after rearranging an expression using other laws. And there's an example just below, and you'll see that it does make sense to be able to use this, and makes things a lot easier to read. Remembering the laws. Remembering it can be useful. If you're trying to simplify expressions, it's often more convenient if you don't have to keep looking them up, and it helps you keep your mind focused on the expression and not trying to work out which law applies. It's practice, practice, practice. And remember, all of the things in Boolean algebra, the laws are logical. You have to make time remembering them if you understand why they work. You'll also notice there is a reflection between and or in a lot of the laws. This is known as duality. You can take advantage of this to reduce the amount of time you need to remember in order to recreate the laws. That's the end of this presentation, and we've covered the basics of the rules. You can see below our contact information and also how to get on to the wiki, which gives more information and also provides a PDF of this presentation for you to download and use to help you learn and remember these rules. Thank you for taking the time to listen, and hopefully we've improved your understanding of Boolean algebra.